I'm Titration, and welcome to this epic chemistry presentation. You've seen me in such other fine quality epic chemistry videos as Titration Introduction. It's all about me. And acid and base, they're opposites of each other? Now, in the previous video, I talked to you guys about what was the idea behind the titration. Now, we're going to look at solving a titration problem. Now, this is going to work when basically you have one acid to one base when we work with this, because there's a nice little cute formula for it. So I have a problem here. It says you are a chemical researcher's assistant and you're going through the chemicals cabinet. Your boss, who normally does the titrating, has already gone home as it is Friday and he wants to see the movie Avengers: Age of Chemtron. You have a bottle of 1.5 molar of HCl. There's another bottle labeled NaOH, but there is no concentration as that part of the label had been ripped off by an unhappy worker. You take it to the lab where you titrate it. You use the following balanced reaction, and here you go. Where we have NaOH and HCl, we get H2O and NaCl, and yes, it is balanced. So you found it took 25 milliliters of this HCl to reach the end point with the 15 milliliter of the unknown NaOH. What is the concentration of NaOH? Now, if you're not familiar with terms like end point, for example, or titration, then I would recommend you catch my previous video where I introduced the idea of titration to you guys. So the first thing we want to do is we got to write down all the information that we've got, which means that physically you've got to go through and look at the problem and start analyzing what's happening. So in this case here, I don't know why, in this case here, we have a molarity. We have a concentration of our acid, okay? We have an NaOH, but we have no idea what the molarity is. Okay, so that's probably what they want us to find. And then here we have a volume for the acid. Here we have the molarity of the acid. Okay, we have a volume of our base, and then over here we have the molarity of our base, which we don't know it. That's what we're trying to find. So this is what we have. We needed some key pieces of information. The only way to get those key pieces of information is you've got to read the problem carefully. Okay, so first thing is we write down all the info that we have. Okay, I already did that for us. Okay, however, because we're dealing with molarity, and again, if you don't know what I'm talking about, check out the molarity playlist. It covers everything there. Otherwise, I'm assuming you are following along on this. So here's molarity, okay? But one of the things about molarity, we know that the formula for molarity is moles over liters. But wait a minute. These are in milliliters. Well, typically, yeah, because we're not going to do titrations in these gigantic liters. We're not. We're going to use it in milliliters. So that probably means we're going to have to change these from milliliters to liters. Now, if you're not familiar with the metric system, then you need to know this little important fact, that it takes 1,000 milliliters to equal 1 liter. So these, if we change them to liters, you're going to have to divide by 1,000. They're going to be very small numbers, right? So in this case here, when we go, we're going to have 0.015 liters, and here it'll be 0.025 liters. Okay? So I have now converted those milliliters into liters, so we're almost ready to go. Now, there is a fairly simple formula that we can use for this, and this works perfectly without any adjustments, where we look at these and we notice, hey, for every one of these H's that are given off, we're going to have one of these OH's given off. Perfect. Just what we needed, because remember, we were titrating till we got to that end point. Okay, so we can go ahead and we can take advantage of this formula, molarity
m1v1, molarity of the first solution times the volume of the first solution is equal to the molarity of the second solution times the volume of the second solution. So that's what we have. Okay, now that's just a question of let's go and pick. Let's go ahead and we'll pick through that. So we can go ahead, and it doesn't matter which one, one or two, doesn't matter which one is the acid or the base, as long as you're staying with it. So I'm going to go ahead, I'm going to have this be my acid, so I'm going to have 1.5 molar multiplied by, let's see, 0.025 liters is equal to X molarity multiplied by 0.015 liters. So that's what we have. Okay? Now we just go ahead and we solve for X. Alright? So we can go ahead, let's go with the next step here. So 1.5 multiplied by 0.025 liters divided by 0.015 liters is equal to X. As we just went ahead and notice I cannot ignore this 0.015. I had to divide it out so that the X would be by itself, and then what we do to one side of the equal sign, you have to do it to the other like this. Okay? And then you go ahead and you divide it. And you, let's see, I don't have, here's my calculator. So let's go on. I'm going to go ahead with the calculator on this. So I got 1.5 times 0.025 equals, and I've got here 0.0375 over 0.015 liters. So this is what we have. Okay, you'd say, but wait a minute, where's that coming in? Well, remember, this is molarity, right? And this is liters. Molarity times liters equals moles, which is what we went ahead and we calculated here. So 0.0375 divided by 0.015 equals, and we end up getting, for our final answer, ladies and gentlemen, as we move through, 2.5 molarity. So that is it. That is our 2.5 molar solution. That's the concentration of our beloved NaOH. So the formula to be using m1v1 is equal to m2v2. Now this only works if you have one OH to one H. If it's more than that, then that's different. You have to do something else different, and I would present that in another video at another time, but not for here. Hey, I'm Titration, and I hope this video has benefited you. Until then, catch you on the flip side.